Hello, my dear students, mainly of class 10. In the chapter Trigonometry, we have learned all the basic concepts which are required to solve the problems of exercises of Ncert basically. So I taught you all the concepts like ratios, identities, and ratio for particular angles like 0 degree, 30 degree, 45 degree, 60 degree, and 90 degree. I taught you how to correlate identities as well. So now on the basis of all the discussion we made, today I'm going to make you understand how can we utilize all these basic concepts to solve problems, to find the answers of the given questions. And this chapter is very important. Basically, trigonometry is very important because in examination we're going to get more marks from this chapter, as well as the application of trigonometry followed by this chapter is also of the great importance. So this chapter trigonometry is not important only for this class, but it is also very important for your next class like class 11 and class 12. These basics which we have been learning the last few days is going to play a vital role to make you understand all the concepts of class 11. Because mainly in physics, in mathematics, you are going to get trigonometrical concept utilized everywhere, anytime, anywhere in each chapter of physics as well as in chapter of mathematics. So trigonometry can be inserted in any of the chapters of mathematics in class 11. You can see all these things the next year. But today I'm going to start the exercise problem of NCERT. I'm going to make you understand how can we solve the problems of NCERT exercises, and what are the main concepts which we have to use while solving, and how can you understand which identity is going to be utilized in solution or finding the solution of the given problem. So I'm going to do all this thing for you. Thank you for watching, as well as please subscribe my channel to get new videos, to new updates, and as well as basic concepts. As time passes, you are going to realize that yes, this channel is very helpful for you in making your concepts strong for class 10 and coming years as well. So please do subscribe my channel and keep learning. I'm going to start NCRT's solution for you all. So now let us start solving the problems. So here I'm going to start with exercise 8.3 NCRT class 10, and I pick the question number 4 because there are 10 problems which are very crucial and very important for us. So now here we have to understand how can we prove these identities using all identities and basic concept what we have done. So the first question says what that, so on side of LHS you can see what is given. So we're going to solution for the side of LHS. What we have is we have cosec theta minus cos theta equals to, so cos theta minus cos theta square is given. Okay, this is what the given is. Now we have to prove this 1 minus cos theta divided by 1 plus cos theta. That is what the RHS is. Now what we do, we know that sine theta is a reciprocal of cosec theta, as well as cosec theta is the reciprocal of sine theta. So I'm going to utilize the same. So now what I do, I simply write this cos थीटा इज 1 by sin थीटा. अब देखो हमें ये पता है sin थीटा इक्वल टू 1 by cos थीटा होता है या फिर cos थीटा इक्वल टू 1 by sin थीटा. तो यहाँ पर हमें cos थीटा दिख रहा है, ये cos थीटा है. इस cos थीटा की जगह हम 1 by sin थीटा प्लेस करेंगे. ठीक है, तो देखो आप मैंने कर दिए. और हमें ये भी पता है आइडेंटिटीज जो मैंने पहले बता रखा है, आइडेंटिटीज आपको बताया मैंने कि cot थीटा को भी आप लिख सकते हो cos थीटा by sin थीटा. तो बिल्कुल आप देखो यहाँ पे हमें cot थीटा दिख रहा है. इस cot थीटा की जगह हम बिल्कुल ये आइडेंटिटी यूज करेंगे cos थीटा बाई sin थीटा. तो हम लिख दें cos थीटा बाई sin थीटा square. Okay, so now what do, we simply take LCM of it first of all. Okay, take LCM of it like this. We'll get sin theta as LCM only. So now in numerator we'll get 1 because there is sin theta. Sin theta divided by sin theta gives us 1, and 1 is multiplied to this numerator, 1 gives us 1. Okay. Similarly, sin theta divided by sin theta gives us 1. When 1 is multiplied to this cos theta, we'll get cos theta square. Okay. Now what we get? Now we have to take this square separately for numerator as well as for denominator. Okay, we did it. Now what we do? We'll leave this numerator as usual. Okay, 1 minus cos theta square, and we write this sin square theta as 1 minus cos square theta. Why? What is in by it? We know that identity number 3, sin square theta plus cos square theta equals to 1. Okay, the basis of that, sin square theta can be written as 1 minus cos square theta. Okay, so this is what is happening. Here we have sin square theta, here as well we have sin square theta. तो हमने sin square theta की जगह 1 minus cos theta प्लेस किया. ओके, तो आपको समझ में आ गया होगा. अब नेक्स्ट स्टेप क्या है? तो नेक्स्ट स्टेप में हम क्या करेंगे? we leave this cos theta square 1 minus cos theta as usual. और आप नीचे में अब देखो, आप इसे स्क्वायर डिवाइड करो. आप देखो दिख रहा होगा आपको ये बिल्कुल ए स्क्वायर माइनस बी स्क्वायर. ए की जगह हमें 1 का स्क्वायर दिख रहा और बी की जगह cos थीटा का स्क्वायर दिख रहा. तो ये ए स्क्वायर माइनस बी स्क्वायर जानते हैं हम कि ए प्लस बी और ए माइनस बी. सो बिल्कुल हम वही यूटिलाइज करेंगे. अब अब हम लिख सकते हैं 1 प्लस cos थीटा एंड 1 माइनस cos थीटा. ठीक है. अब देखो कुछ न्यूमरेटर में और डिनोमिनेटर में कुछ चीजें सेम है. अब बिल देख रहा हूँ 1 माइनस कॉस थीटा स्क्वायर यहाँ है और 1 माइनस कॉस, एक स्क्वायर एक 1 माइनस कॉस थीटा कट गया न्यूमरेटर से भी डिनोमिनेटर से भी, हमने कैंसिल कर दी. और हमारे पास अब जो बचा लिख रहे हैं 1 माइनस कॉस थीटा डिवाइडेड बाई 1 प्लस कॉस थीटा विच इक्वल्स टू आवर RHS. Okay, this is how we have solved this problem. Okay, you can see from here. Again, I'm going to describe this here problem. What I did from here, simply we took first of all LHS, which is equals to cosec theta minus cos theta square. Okay, and we have to stop here for some while and think how can we proceed further. Directly by opening this square, are we getting some green teas or something else? No, we are not getting directly. So what we do simply, we started doing this cosec theta as can be written as 1 by sin theta. Similarly, this cos theta can be written as cos theta. This cot theta can be written as cos theta by sin theta, as I have mentioned here. तो आपने देखा हमने एलसीएम ले लिया, दोनों के डिनोमिनेटर सेम है तो एलसीएम तो sin थीटा ही होगा. उसके बाद 1 माइनस cos थीटा ये न्यूमरेटर में हमें मिल गया. उसके बाद हमने क्या किया, इस स्क्वायर को अलग कर दिया न्यूमरेटर के लिए और डिनोमिनेटर के लिए. आप देख रहे हो स्क्वायर को मैंने दोनों जगह अलग किया. अब उसके बाद हमने ऊपर वाले न्यूमरेटर को बिल्कुल ऐसे ही छोड़ दिया और नीचे वाले न्यूमरेटर को हम लिख सकते हैं 1 माइनस कॉस स्क्वायर थीटा. कैसे? हमें ये पता है आइडेंटिटी से कि हम जानते हैं कि साइन स्क्वायर थीटा प्लस कॉस स्क्वायर थीटा गिव्स अस 1. So therefore sin square theta can be written as 1. This plus is there, so it become minus cos square theta. So in the place of sin square theta, we can put what? 1 minus cos square theta. Again, we concentrate here and find that yes, this system is working as 1 ka square and cos ka square theta. So we can write a square minus b square. So we can write 2a plus b. Sorry, this is 2 for square. A plus b, a minus b. Okay. So I did the same. 1 plus cos theta, 1 minus cos theta. अब देखो न्यूमरेटर में हमारे पास दो बार 1 minus cos theta और डिनोमिनेटर में 1 माइनस कॉस थीटा एक बार. तो एक बार ये कट गया तो एक बार हमारा ये बच गया और ये बच गया. हमने उसे बिल्कुल नीचे लिख दिया और देखा बिल्कुल ही आरएचएस के बराबर है. यही हमें प्रूफ करना था. अब आपको होप है समझ में आ गया होगा. आई होप दैट यू अंडरस्टैंड ऑल दिस बेसिक कॉन्सेप्ट्स एंड हाउ आई हैव यूटिलाइज्ड द नोन आइडेंटिटीज व्हिच हैव बीन प्रूव्ड अर्लियर एज वेल. सो प्लीज concentrate here and try to write down all these things and try to understand. चलिए अब हम बढ़ते हैं दूसरे क्वेश्चन की ओर. एक्सरसाइज 8.3 का क्वेश्चन नंबर 4 का सेकंड क्वेश्चन ये बिल्कुल सामने आपकी स्क्रीन पे ये हमें बोल रहा है कि देखिए आपके पास एलएचएस में कुछ cos a डिवाइडेड बाई 1 प्लस साइन ए प्लस 1 प्लस साइन ए डिवाइडेड बाई cos ए, इसे इक्वल्स टू प्रूफ करना है 2 sec थीटा के. से इसके इक्वल्स प्रूव करना। तो अब इसकी मेथड क्या है, ट्राई टू अंडरस्टैंड। देखिए, जब भी ऐसे एंटिटीज वाले प्रॉब्लम आपको आए, आप थोड़ी देर रुके और एलएचएस या आरएचएस किसी एक को पकड़े और जज करें। जैसे मैंने मान लो इस प्रॉब्लम के लिए एलएचएस को पकड़ लिया, और इस एलएचएस में मैं थोड़ी देर सोच रहा हूँ क्या हम इस पूरे पार्ट को आइडेंटिटीज के करीब कैसे ले जाएं। जो आइडेंटिटीज हम जानते हैं, उन आइडेंटिटीज के करीब हम इसे कैसे लेके जाएं। तो हमें डायरेक्ट कोई आइडेंटिटीज इसमें दिख नहीं रहा। अब देखो, इसमें कोई डायरेक्ट आइडेंटिटीज नहीं दिख रहा हमें, जो हमने पढ़ रखा, किसी भी तरह की कोई डायरेक्ट आइडेंटिटीज यहाँ देखने को नहीं मिल रही है। ठीक है, तो अब हम क्या कर सकते हैं। जब डायरेक्ट को आइडेंटिटीज डायरेक्ट अप्लीकेबल नहीं हो रहा है, तो हमारे पास एक तरीका बचता है, आप इसका एलसीएम लीजिए। चलिए हम एलसीएम लेके देखते हैं क्या होता है। ठीक है, तो एलसीएम हमारा हो गया कॉस ए 1 प्लस साइन ए। ठीक है, अब जब हमें पता है कि इस एलसीएम से डिनोमिनेटर को डिवाइड करेंगे तो 1 प्लस साइन ए, 1 प्लस साइन ए हमें क्रॉस हो जाएगा, कैंसिल हो जाएगा, कॉस ए बचेगा, और कॉस ए जाकर ऊपर मल्टीप्लाई होकर हमें कॉस स्क्वायर ए मिल जाएगा। बिल्कुल ऐसे ही जब इस एलसीएम को हम कॉस ए से डिवाइड करेंगे, विल गेट ओनली 1 प्लस साइन ए। सो अब 1 प्लस साइन ए जाके मल्टीप्लाई ऊपर हुआ, तो विल गेट व्हाट, 1 प्लस साइन ए का स्क्वायर। ओके, वी गॉट दिस। नाउ अगेन व्हाट वी डू, again we follow the process like this is square. Again we're not getting any direct formula, so we open this square. Okay, we'll get a square plus b square plus 2 sin a. ठीक है, a square plus b square 2 sin a means 2ab. This is 2ab, this is what, this is a square, this is b square plus 2ab. Okay, we got this. Again numerator we leave it as usual like this, cos a 1 plus sin. Okay, we are not going to multiply it. Why? we are going to learn it later. Okay, अब देखो, अब ध्यान से कि आप इस cos स्क्वायर ए को और sin स्क्वायर ए को साथ रख लो। अब एक आपको आइडेंटिटी सी फीलिंग आ रही होगी, यहाँ sin स्क्वायर ए प्लस cos स्क्वायर ए को हमने साथ रख लिया, और ये प्लस 1 यहाँ पर और 2 sin ए हमने यहाँ। ठीक है, अब आप ध्यान से देखो, ये आपके आइडेंटिटीज में आ रहा है। ये जो चीज आप देख रहे हो, ये साइन स्क्वायर प्लस, हमें पता है कि साइन स्क्वायर ए प्लस कॉस स्क्वायर ए गिव्स अस साइन स्क्वायर ए प्लस कॉस स्क्वायर ए गिव्स अस 1. Okay, this is identity. So we can write 1 in the place of this complete term. Okay, so I write 1 plus 2 sin a divided by cos a 1 plus sin a. Okay, अब हम क्या करेंगे, अब ध्यान से देखो, तो इसे हम लिख सकते हैं 2 plus 2 sin a divided by cos a 1 plus sin a. ठीक है, तो अब ये थोड़ा देर हम रुके for few seconds and think how can we proceed further. Yes, अब हमें क्या दिख रहा है कि this 2 is common in both, so we can take out this 2 like this, 2 1 plus sin a. Okay, in denominator we left with cos a 1 plus sin a. Okay, now we get what, you can see that this 1 plus sin a 1 plus sin a got cancelled. What we left with now, in numerator we left with 2, in denominator we have cos a. So we can write this as 2 into 1 by cos a. So this 1 by cos a can be written as sec a. Why? Because we know sec a is the reciprocal of cos a and cos a reciprocal of sec a. So in the place of 1 by this cos a, we can write 2 sec a. This is what the RHS was, and we have proved it. Okay, I hope you got the solution. Once again, I'm going to repeat the same. Again, in the first instance, what we have to do, when we see the question, we have to stop for a while and find whether any identities could be applicable or not. We found from here that yes, directly no identity can be utilized here, so we proceed in normal way. What we did, हमने इसका LCM लिया सिर्फ, ठीक है, LCM लिया ऐसे, और हम जानते हैं एलसीएम को जब डिनोमिनेटर से डिवाइड करते हैं, जो कोसेंट आता है उसे ऊपर मल्टीप्लाई करते हैं, तो कोसेंट इस केस में हमारा कॉसे आएगा, और कॉसे को कॉसे से मल्टीप्लाई करके हमें क्या मिल गया, कॉस स्क्वायर ए मिल गया। बिल्कुल ऐसे ही जब इस एलसीएम को हम इस डिनोमिनेटर से डिवाइड करेंगे, वी लेफ्ट विथ वन प्लस साइन ए, जो ऊपर जाके वन प्लस साइन ए से मल्टीप्लाई होके बिल्कुल स्क्वायर बना देगा, क्योंकि दोनों सेम है। ठीक है, अब फर्दर, अब फिर हमने देखा कि हाँ डायरेक्ट क्वांटिटीज तो यहाँ लग नहीं रहा, तो हमने क्या करा, इस स्क्वायर को खोलने की कोशिश की। देखिए ए स्क्वायर प्लस बी स्क्वायर टू ए बी, ओके, देयर इज वन एज वेल एज इन द फॉर्म ऑफ बी, okay. So now when you open, we got some ideas of identities. This is cos square and sin square were collected together here, okay, we collected it here. So now this is plus what, 2 sin a, this become 1. As we know, sin square a plus cos square a gives us 1, so I can write 1 in the place of this sin square a plus cos square a plus 1 2 sin a. Now next step, I just added these two. 1 plus 1 gives us 2, and there is 2 sin a, and we left this denominator as usual. So now what I did, we can see that 2 is common in this both terms. So I took 2 as common, and we left in denominator as 1 and sin a. And in denominator we have cos 1 plus sin a. We cancel this 2 and left with 2 cos a. I can write this 2 cos a as 2 into 1 by cos a, or this cos a can be written as sec a, as we know that this sec a is the reciprocal of cos a, or cos a reciprocal of sec a. So this is what we have to prove in RHS. So we got LHS equals to RHS. Hope you understand, and I repeated the solution as well. Okay, now it is the time for the question number 3 of exercise 8.3. Okay, this third part of question number 4. So basically this problem is very important because it has already appeared in board exam earlier as well. So we have to understand how can we utilize identities and all concepts to prove such identities as well. So now I was going to start again. I'm repeat the same thing. First of all, whenever you get problem of this proof, what you going to do? You have to stop yourself and think: can we apply identities directly, or any kind of identities can be applied here? अगर आपको लगे कि हाँ कोई भी एक आइडेंटिटी जो इस पे अप्लाई हो सकती है, तो हम बिल्कुल वहां से शुरू करेंगे। आप ऐसे बहुत सारे प्रॉब्लम कर लोगे, कम से कम 20 से 25 से 30 प्रॉब्लम करने के बाद आपको रियलाइज होगा कि आप खुद ब खुद ये फील करोगे कि हाँ ये प्रॉब्लम हम कैसे इनिशिएट करेंगे, बिकॉज द इनिशिएशन ऑफ सच प्रॉब्लम्स इज वेरी इंपॉर्टेंट। वंस यू इनिशिएटेड वेल, यू कैन इजिली प्रूव कंसिक्वेंसली ऐसे चीजों को। ठीक है, तो चलो हम एक बार आगे बढ़े, देखें कैसे करते हैं हम इसे। देखो डायरेक्ट क्वांटिटी दिख नहीं रहा, हम टेन थीटा को, इस टेन थीटा को हम लिख सकते हैं साइन थीटा बाई कॉस थीटा। बिल्कुल ऐसे ही हम वन कॉट थीटा को लिख सकते हैं कॉस थीटा बाई साइन थीटा, और ऐसे ही इस कॉस थीटा लिख सकते हैं कॉस थीटा बाई साइन थीटा, और इसे क्या लिख सकते हैं साइन थीटा बाई कॉस थीटा। और हमने ऐसा क्यों लिखा, क्योंकि हमें ऑलरेडी आइडेंटिटीज पता है, हम अलग से कहीं से नहीं ला रहे। हमें पता है कि sin theta by cos theta gives us tan theta, whereas cos theta by sin theta gives us cot theta. This is what simple identity. In the previous lectures of mine, I have proved all these things from where we got these identities as well. Okay, so we directly understood this, and here we can see that here we have tan theta, so I utilize this sin theta by cos theta, and we have cot theta, so I utilize cos theta by sin theta, whereas we have cot theta, so I converted this cos theta into cos theta by sin theta from here only. Okay, again this is tan theta, I utilize this identity and write it as sin theta by cos theta. This is what I did. The next thing is what we can do. So we can leave it as is, and we take LCM here. Okay, when we take LCM, we'll get what, this is sine theta, and this sine theta goes here, this sine theta goes here, and make it sine theta. Okay, so this is sine theta, and this will remain as usual because LCM is sine theta, and here denominator is also sine theta. Okay, now in this case, this is cos theta by sine theta, and again we take LCM as cos theta. This cos theta goes here, we'll get what, cos theta minus sine theta. Okay, now next what we do, we simply divide them. Okay, what we get after division is sin theta by cos theta into sin theta is here and sin theta minus cos theta is here. Why we did it? As in junior class of ours, we studied what if we have 3 by 2 by 4 and 6 by 8, what we do? We simply, this is the main division, we convert division into multiplication. Again, we reciprocate this. Okay, we'll get 8 by 6. So simply I reciprocated it. Okay, there sin theta is above and sin theta minus cos theta is below. Okay, similar thing would be done here as well. This is cos theta by sin theta. Okay, and let me erase it to free the space to solve problems. So I hope you understood this concept. Now next step is what? I've written cos theta by sin theta, and again this cos theta come up, and this cos theta minus sin theta will be here only. Okay. Now what do we do? We multiply now. We'll get what? Sin square theta divided by cos theta, and this is sin theta minus cos theta. Again we multiply here. We'll get what? Cos square theta. This is sin theta cos theta minus sin theta. Now stop here and find some way to go ahead. Okay, what can that be? So now अब यहाँ से आप देखो कि हम प्रोसीड कैसे करेंगे. डायरेक्ट तो कोई आइडेंटिटीज लग नहीं रहा. सो हम एलसीएम करेंगे फिर से. लेकिन एलसीएम को और सुटेबल और इजी बनाने के लिए हम क्या करते हैं, जैसे हमारे पास देखो आप यहाँ पे साइन थीटा माइनस कॉस थीटा या कॉस थीटा माइनस साइन थीटा. अगर इस कॉस थीटा माइनस साइन थीटा को हम साइन थीटा माइनस कॉस थीटा किस तरह से बना ले, तो हमें एलसीएम लेने में बिल्कुल आसानी हो, क्योंकि यहाँ साइन थीटा माइनस कॉस थीटा और साइन थीटा माइनस कॉस थीटा कॉमन हो जाएंगे और हम आसानी से एलसीएम कर सकते हैं उनका. तो इसके लिए हम क्या करेंगे नेक्स्ट स्टेप में, आइए देखते हैं. साइन स्क्वायर थीटा इज देयर एंड विल गेट व्हाट? दिस कॉस थीटा sin theta minus cos theta. Okay, I took minus common from here. Okay, I took minus common from here. How? When I took minus common from here, this sin theta come first and then this minus cos theta, क्योंकि अब जब वापस से ब्रैकेट आप ओपन करेंगे, there is plus plus minus minus sin theta minus into minus, this minus into minus when multiplied gives us plus cos theta. Okay, so that means we can do this as well. Now in the next step, what we do, write as sin square theta. This is cos theta sin theta minus cos theta. We get plus minus minus. This plus into minus gives us minus. Okay. We left with what? Cos square theta divided by sin theta, and this becomes sin theta minus cos theta. Now you can see we can take LCM very easily. How can we take? We can write this sin theta and cos theta once because they are common, and we'll write sin theta into cos theta here. So this become LCM of the denominators. Now here you can see the presence of cos theta into sin theta minus cos theta. When divides this, we left with only sin theta. Okay, so sin theta when goes in numerator, it makes this as sin cube theta, like this. Similarly here as well, we have this sin theta and sin theta minus cos theta presence here. Okay, this is the presence of these two, and we left with only cos theta after division. So cos theta when goes here, it makes it cos cube theta. Okay, this become cos cube theta. So now in class 9 we studied about identity. What was the identity? A cube minus b cube. You can see here in numerator we are getting sin cube theta minus cos cube theta. It can be transformed in this form. And what is the identity for this? We have studied in class 9. This is a minus b, a square plus ab plus b square. Okay, again aq minus bq gives us a minus b, a square plus ab plus b square. So we're going to utilize it here. Okay, so now this become a minus b. Okay, in the place of a we have this sin theta, because this sin theta can be written as sin theta's cube and this cos theta as cos theta's cube. So in the place of a we have this sin theta, and the place of b we have cos theta. Okay, so this is now a square means sin square theta plus b square can written ahead as well, so no problem. cos square plus AB means sin theta into cos theta divided by this whole term. Okay, sin theta cos theta sin theta minus cos theta. Okay, now what we do, we can see this is sin theta minus cos theta. Again here we can see this is sin square theta plus cos square theta, and we know the identity is there. Sin square theta plus cos square theta gives us 1, so we write 1 in the place of this. So now we left with sin theta into cos theta here. Now in denominator again, whatever thing we are having, we write the same. This is sin theta minus cos theta. Okay, so now you can see this is sin theta minus cos theta. Sin theta minus cos theta get cancelled, so we have cancelled this too. I can change the color as well like this. Okay, so now they're cancelled. Now what we left with is 1 plus sin theta into cos theta divided by sin theta into cos theta. So now we can distribute this denominator as well. Now how can we distribute? We can write this as sin theta and cos theta, and we write sin theta into cos theta divided by sin theta into cos theta. Okay, what we do now? We can cancel this two and get 1, and here what we can write is, so this 1 by sin theta can be written as 1 by sin theta into 1 by cos theta, and this is 1. We know the reciprocal of sin theta is cosec theta, so we can write cosec theta, and we know the reciprocal of 1 by cos theta is sec theta. You can write sec theta plus 1. So at last we get what? 1 plus sec theta into cosec theta. This is what the RHS is. So I think we have proved this. So I hope you understand, although this is a lengthy sum, but we can solve it easily by concentrating some identities, and some algebraic calculation can be done here to solve it very easily. Hope you understand this, and please note down all the solutions so that whenever you revise it again, only revision going to make you understand how can utilize this sum in other problems as well. If you do not revise, you are not going to utilize all these things at one go in examination. So if you want to do it successfully, then you have to revise, you have to note down it twice and thrice, and understand how can we utilize these concepts, how can we use these identities other problems as well whenever such situation occurs in future as well. Okay, this is how we can solve the question number 3. Well guys, now in front of you is question number 4. For sake of saving time, I simply solve this problem for you such that we can save our some time and utilize in the explanation part of the solution. Okay, so now in front of you I have just mentioned the solution, I have done the solution, I'm going to explain each and everything of the solution. Now you can see this is the 1 plus sec a divided by sec a, and we have to prove it as sin square a divided by 1 minus cos a. Okay, we have to prove it. Now stop for some while and find what can we do there. Directly we can utilize any identities, but one entity can be utilized, that sec theta. This sec theta is the reciprocal of cos theta, so I can write this sec a, sorry, as 1 by cos a. Similarly, this sec a can be written as 1 by cos a. We took the LCM here, so we got the LCM as cos a. So this cos a goes here and make it cos a, and 1 remains as usual because there is cos a in denominator. When divide this LCM by this cos a, we'll get 1. So 1 multiply 1 by 1 gives us 1. Okay, so this is 1 by cos a. Now I took the reciprocal of this because this is the main division, as I did in the previous question as well. This is cos a plus 1 divided by cos a, and this cos a by 1. This cos a get cancelled. Okay, after making them reciprocal. So now left with 1 plus cos a. So now I took again RHS. The RHS was what? Sin square a divided by 1 minus cos. I took the same. So now sin square a can be written as 1 minus cos square a, as we know the identity is sin square a plus cos square a gives us 1. We know sin square a plus cos square a gives us 1. From here only this sin square and this cos square a can be taken on this side, and it becomes what? 1 minus cos square. Okay. So now again, as we have utilized the same step earlier as well, this is become a square minus b square. Okay, so this become a plus b and a minus b. I rewrite it, there's a multiplication in between. So in denominator we have 1 minus cos a, in numerator as well we're getting 1 minus cos. These two got cancelled, we left it 1 plus cos a. Okay, So now earlier as well, we get 1 plus cos A in the solving RHS. We are getting 1 plus cos A. That means we got this LHS equals to RHS. Okay. This is what the LHS is. So we proved the question. Okay. Now next problem is question number 5. Okay. Here in this problem, we have to understand one basic concept, and there is a particular method to solve this problem. Question number 5, that is cos A minus sin A plus 1 divided by cos A plus sin A minus 1 gives us cosec A plus cot A. For this, there is one trick which we have to play here. We have to understand what can we do. The main purpose here of this trick is, anyhow we must got minus 1. Anyhow we have to get minus 1 in numerator. So we have to manage to get what? Minus 1 in numerator. So this can only be possible when we divide this entire term by sin A, sin A, sin A. Because when this sin A get cancelled, we get minus 1. So I followed the same step here as well. So you can see here. Okay. So now I divided this numerator by sin A only. Okay. Here we write in sin A, sin A, sin A. Again in numerator as well, there is sin A, sin A, sin A. So particularly this cos A by sin A gives us what? Cot A. Whereas this sin A by sin A gives us 1, because due to cancel we get 1. 1 by sin A is the reciprocal of what? Cosec A. So I have written this here as well. And cos A by sin A gives us what? Cot A. We know the identity as well. So now this cos A by sin A also gives us cot A. Whereas this sin A sin get cancelled gives us 1. 1 minus sin A is, cosec A. I know. And we also know that this sin A is the reciprocal of cosec A. Where is this cosec is reciprocal of sin A? Okay. Similarly, now what we did. So in the place of 1 now you can understand the importance of making minus 1. In the place of 1, we can write cosec square minus cot square. Why? Because we know cosec square is cosec square minus cot square gives us 1. This is one kind of identity we have already proved in our lectures. Okay. So this is what. So therefore, in the place, what we did, we simply write this 1 as cosec square A minus cot square A. Okay. So now I have written this cosec square A minus cot square A. Now again we'll get A square minus B square. So I did A plus B, A minus B. Okay. Simply, and this term remains as usual. And in numerator as well, I haven't done any expansion or anything. Okay. So now here you can say, from here cot A plus cosec A and cot A plus cosec can be taken common from this two term. So I took the same. Cot A plus cosec has been taken common, and we left here with 1 because I have taken this complete term out. So 1 is there, and minus left here, and left with this cosec A minus cot A because this term has taken here. Okay. So now what to do? When I open this bracket and multiply minus 1 inside, I will got this minus cosec A and minus 1 plus cot A. And in numerator you can see there is cot A plus 1 minus cosec A, cot A plus 1 minus cosec A. Okay. So now these two got cancelled. We left with cot A plus cosec A. That is the RHS. So we have proved it. So simply the purpose of making minus 1 is that we have to apply this formula cosec A, cosec A square minus cot A square, because ultimately the signs of all these terms in numerator must be equal to the signs in numerator as well. So we have to make minus 1 in numerator. So you can practice and you can find what is the reason behind making minus 1. So this is what the question number 5 gives us. Now question number 6. Okay, this is quite simple problem. In LHS we have under root 1 plus sin A divided by 1 minus sin A, whereas in RHS we have sec A plus tan A. So now what we do simply, now we cannot use any direct identities here. Okay. So now we try to force some identity on this problem. How can we force it? What we did, we simply multiply this both term by 1 plus sin A, 1 plus sin A. What was the purpose? Because when you do this, we get 1 plus sin A square, both are same, so there is a square, and this become A plus B, A minus B, and this, that means A, this is A, this is B, this is A, this is B, A plus B, A minus B, will get what? A square minus B square. So we got the same, this is A, so we'll get 1 C square, this is B, we will sin square A. Okay. So now what do you do? And we know that this 1 minus sin square A gives us what? Cos square A. As we know the identity, the sin square A plus cos square A gives us 1. From there only I got this. So in the place of this 1 minus sin square A, we can write cos square A. So I did the same here. So now we have to open this square root as well. So when you open this square goes and we'll get 1 plus sine a, and similarly when open this square root, this square goes and we'll get cos a. Okay, so now this become, now I can simply distribute this denominator over this numerator, will get 1 plus cos a sin a by cos a. So 1 plus cos a gives us sec a, as we know cos a and sec a are spoken of each other, and sin a by cos a gives us tan a. We have utilized it earlier as well in many problems. Okay, this is what the RH is cos. So we proved it. Okay, now what about question number 7? So now here we have sin theta minus 2 sin cube theta divided by 2 cos cube theta minus cos theta equals to tan theta. That is what we have to prove. Question number 7. Please see the question number 7 in your book as well. So now what we do? We can utilize direct any direct identity is what we have learned. So one thing can be done here is sin theta is here as well, sin cube theta is there, cos cube theta and cos. So we can take sin theta common from above and cos theta common from below. So I did the same. We took this sin theta as common, left with 1 minus 2 sin square theta. Here as well, we have taken cos theta out. So we'll have with 2 cos square theta because cube में से एक बाहर निकल गया. 2 cos theta and cos theta complete बाहर निकल गया. So one left here. Okay. So now this is what we have done. So now in the place of sin square theta, I can write this 1 minus cos square theta. Why? What is it? Because we know that sin square theta plus cos square theta gives us 1. So in the place of sin square theta, I can write 1 minus cos square theta. Okay, so I wrote the same. Yes. So now I multiplied this 1 minus this 2. This become minus 2 and plus 1 minus cos square theta. Okay. So 2 cos square theta from here, and this become minus 2 and plus 1 gives us minus 1. So I have written minus 1 here. Okay. In denominator, we left it as usual, and now this cos square 2 cos theta minus 1 and 2 cos theta minus 1 got cancelled. We read with what? Sin theta by cos theta. So this is the tan theta is the RHS. So we proved it. Quite simple. Okay. Now it's the time for question number 8. Okay. So now this question also appeared in board examinations several times. You can see the previous year as well. So now the next thing is this. What is your next thing? Where is that? Wait. Yeah. This sin A plus cosec is whole square. Cos A plus sec A whole square equals to 7 plus 10 square A plus 40 square. Okay. So now we have to make the numbers. Okay. And we start opening. We do not have any idea of direct using of any application of identities. What we did is simply open the bracket in both the cases. So what we did is sin A plus cos A. This is sin square A plus cos A square A, 2 sin A and y. This is A square plus B square plus 2AB. Similarly as well, A and B. This is A square, this is B square, this is 2AB. Okay. Similarly, so I collected the term which can come under identities as well. So I took this sin square A एंड कॉस स्क्वायर ए साथ में. ओके, क्योंकि अब तक हम समझ चुके हैं कि साइन स्क्वायर ए कॉस स्क्वायर हमें 1 देगा और हमने इसको बहुत जगह यूज भी किया. उसके बाद देखो आप, ये दोनों एक दूसरे का रेसिप्रोकल है. कैसे? आप साइन ए को साइन ए और कोसेक ए को आप लिख सकते हो साइन ए. तो साइन ए और साइन ए गेट कैंसिल बिकॉज कोसेक इज रेसिप्रोकल ऑफ साइन ए. तो हमें सिर्फ यहाँ से 2 मिलेगा. सिमिलरली अब देखो यहाँ पे ये कॉस ए और सेक ए भी एक दूसरे का रेसिप्रोकल है. तो कॉस ए हम इसे क्या लिख सकते हैं? 1 by cos A. So cos A got cancelled, we get 2 only. Okay, this 2 is here and this 2 is here. Because these 2 are get cancelled gives us 1 because they are reciprocal of each other. Now what we left with? We left with this cosec square A here and sec square A because this cos square is taken here as well. Okay, now come to the next step. This sin square A plus cos square A gives us 1 and there is 2, there is 2. Okay, I wrote here as well. Now cosec square A can be as 1 plus tan square A. What is it behind it? As we know that a cosec square A minus cot square A gives us 1. So now cosec square A, this cosec square A and 1 plus cot square A, which I wrote here only. Okay, I have written it here. Okay, 1 plus cot square A. Similarly, we know that what is sec square. This is identity. You can see the cosec square A minus cot square theta or whatever you write gives us 1. From where cosec square I can return as 1 plus cot square A. So I wrote this cosec square A here. Similarly, I did here as well. What I did, we know that sec square A minus tan square A gives us 1. Okay. So in the place of sec square A, I can write this tan square goes this side and become plus. So become 1 plus tan square A. So I have written this 1 plus tan square A here only. Okay. Hope you understood this. Okay. So now this is what I have written here. Let me raise. I hope you understood. To free the space. Now here we have 1. So we'll write the next exercise, next problem. Here we go. Now come back. Now what we did? Now so this become 1 here and 1 here. This one are collected. This one 2 plus 2 4 1 5 1 6 1 7 I wrote here, and 10 square A is written here and 40 square A. So this is what we have proved as a RHS. I hope you understand this problem as well. Now next problem is question number 9. Okay, what is in question number 9 is this cosec A minus sin A multiplied by sec A minus cos A gives us 1 by tan A plus cot A. This is also quite simple. So now whatever entity, now you can recognize what we can do with. Okay, what we do, we simply take this cosec A as 1 by sin A because they are reciprocal to each other. Similarly, this sec A can be written as 1 by cos A because cos and sec are reciprocal to each other. So now we took calcium, there is 1, there is 1, we took calcium as sin A. This becomes 1 minus sin A because this sin A goes directly here, it becomes sin A square A, and there is 1 only because sin A get cancelled, we get 1, 1 into 1 gives us 1, here this is 1, when 1 divides sin A, we get sin A as the quotient, and this quotient goes multiplied to this sin A and gives us sin A square A. Okay, again there is 1, this 1 cos A gives us cos A, become 1 minus cos square A. You can see this cos square goes there and make it what cos square A. This is what we get cos square A here. Okay, now we know identity that sin square A plus cos square A gives us 1. Several times I iterated it. Now again I am doing the same. So this 1 cos square A can be written as 1 minus sin square A. So here we have the same thing. Here we can see this sin square A is here. So in the place of 1 minus sin, I can write cos square A, which I did here. Similarly, this sin square A can be written as 1 minus cos square A. So here as well, you can see this 1 minus cos square is present here. So we replaced it this 1 minus cos square A by sin square A. So here it is. Okay, now अब थोड़ा हम काटाकाटी करते हैं. This sin A simply cancelled by one of the sin A, and this cos A cancelled one of the cos A. So in numerator we have cos A and there is sin A. This is what we have to maintain in RHS. Now come to the maintaining LHS. Sorry. So now what about RHS? Okay, RHS is 1 plus tan A, 1 by tan A plus cot A. Similarly, again we know identities of tan A is sin A by cos A and cot A is cos A by sin A. Okay. So similarly, we took the LCM of these two. We'll get sin A cos A. This sin A goes here, make it this sin square A, and this cos A goes here and make it cos square A. Okay. Again, come in. So now what we got, we simply took the reciprocal of it. So now this sin A cos A goes up and this sin square A cos square A comes down. So now with this identity as well. So sin square A plus gives us 1. So I wrote 1. Again in numerator we'll have sin A cos A. This is sin A cos A. As in the previous case I will get sin A cos A. So LHS equals to RHS. This is what we have proved. Now the last question is question number 10. So now this question also very easy. Directly we can use the identities as well. So we take this part. 1 plus tan square A divided 1 plus cot A square equals to 1 minus tan A divided 1 minus cot A square equals to tan square A. Okay. So now what we do, this 1 plus sin square A divided by cos square A. Why? Because tan A can be written as, tan A we know the formula. Tan A can be written as sin A by cos A. So similar thing, there is square, so we squared it and we got this sin square A by cos square A. Similarly, this cot A we know can be written as cos A divided by sin A. So we have squared it, got cos square A by sin A. Again we took the LCM. This cos square goes here, it is here, and this is cos. Again we take this sin square here, this is here, and we took the reciprocal and this become sin It become, I think, sin square a should sin square a should go there. This is sin square a, okay. This is sin square a. Understood? Now from here as well, we know this become what? 1, because this is cos square a plus sin square a. This gives us 1. Similarly, this is sin square a plus cos square a. This also gives us 1. So this is 1, 1. We got sin square a divided by cos square a. So this sin square a by cos square tan square a. Now take the middle term, middle one, that is 1 minus tan a divided by 1 minus cot a. Similarly, again, I know tan a can be written as sin a by cos a. This is identity, and cot a can be written as cos a divided by sin a. So 1 minus sin a by cos a divided 1 minus cos a by sin a. We took the LCM. LCM is cos a. This cos a goes here and make it cos a minus sin a. And cos a is there. Similarly, this sin a goes here. It becomes sin a minus cos a and sin a. We took the square as it is listed here. Okay. Now next thing is that we took this square common here, and this is the reciprocal. We have to make the reciprocal of it. I took the same. Sin a is above, and this sin a minus cos a goes down. Okay. So now this will remain as usual. तो अब देखो ध्यान से, अब हम क्या करते हैं, यहाँ से हम माइनस कॉमन ले लिया हमने। देखो माइनस कॉमन ले लिया तो साइन ए यहाँ आ गया, कॉस ए, बिकॉज हम ब्रैकेट जब खोलेंगे तो प्लस माइनस 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 प्लस कॉस ए आ जाएगा, और कॉस ए यार, ठीक है। साइन ए माइनस कॉस ए इज देयर एज वेल, सो दिस टू आर सेम, सो दे गेट कैंसिल, वी लेफ्ट विद दिस माइनस साइन and sin a and cos a. When you square, when this minus become plus, and this sin a square becomes sin square a, and this cos a square become cos square a. And we know this can be written as sin a divided by cos a square. So this sin a by cos a gives us tan, and square gives us square. So this becomes tan square a. So in the first case as well, we got what? Tan square a. In the second case as well, we got tan square a. This is the proof for the question number 10. I hope you understand all the discussion. So now this discussion is very important for you. Please go through this video twice, thrice, such that you can utilize all the discussion very easily to understand how can we equate this LHS equal to RHS, because it's for sure that such problems going to appear in your examination or boards, in pre-boards, in school examinations. So if you practice at one go, you are going to understand naturally and automatically that where to use what. So if you want to learn this such kind of problems again and again in future as well, you do subscribe my channel, so that it would help me and encourage me to do something more for you. And I will surely going to do something special for you in future as well. You're surely going to get something different from me, which is very difficult to get from somewhere else. So I hope you're going to subscribe my channel and as well as understand what I taught you. Thank you. Have a nice day and happy learning.